Okay, let's get started. Hello, everyone. So, my name's Andrew. I'm a Googler, and I work on the Chrome apps team. I've had some significant launches as of late, but that's not what I'm here to talk about. I've had the pleasure of working on some high-profile projects at Google since I've been there. I've worked on Google Calendar, I've worked on Gmail, Google Docs, and for the last couple of years, I've been working on the Chrome apps platform. So a bit of a change for me from working on actual products to working on developer tools. So that's been a lot of fun, and I'm here to share with you today what that's all about. So first part here is I'm just going to explain kind of what Chrome apps are, what are they for desktop, and what are they for mobile. And then we'll kind of dive deeper into how to build a Chrome app, what are the ups and downs, and what do I see as happening going forward. So, a Chrome app is an app that runs on Chromebooks, and they also run on Windows, Mac, and Linux. And at least this was the definition until a couple years ago when we expanded to mobile as well. So some examples of Chrome apps, like a text editor, a file manager, your Photos app. These are all kind of stock apps on Chromebooks. They're built with HTML, JavaScript, and CSS. Probably not much of a surprise. And kind of the neat thing about them is that they're able to use APIs that go over and above what is available in the open web, we say. So examples are Google Cloud Messaging or Identity, which lets you get a user's authentication, Google authentication token, without having them to type in their username and password. Talk to USB devices, that kind of thing. You install them from the web store. And kind of a key piece of this is that they don't run in a browser tab, so they run in their own window. I'm just going to show what I mean by that. So let's go through an example. Here we are at the Chrome Web Store. One of my favorite apps developed by a colleague of mine is an IRC client here. So permission dialog, add. So you see here actually, I've hidden my doc. Let's show that. So all Chrome apps, one place to find them here is in the apps launcher, and you can see there's I have a few accounts signed into my Chrome instance. So here's CIRC here. There's an Alt tab for it. Here it is over here. Another example is Spotlight, or I have Quicksilver up here. Anyways, they show up as actual applications on your machine. They're not web pages, even though they use web technologies. Yeah, I don't need to show off connecting to an IRC server. So offline by default, I just wanted to add on to this. Not like it's possible to make web pages run offline. It currently takes quite a bit of work to do that. You have to learn how to use app cache and get the user to actually bookmark your page so they can navigate there again. But even with that, I think we've kind of determined it was at least in its current form, a little bit of a failed experiment in that users just don't expect web pages to work offline. Even if they do, the user's not going to try it because they don't expect it to work. So with Chrome apps, we kind of, by putting the icon on their desktop and in the Chrome app launcher, it tells the user, yes, it does work offline, and they will think to try it while offline. So why would you write a Chrome app on the desktop instead of a native app? Well, cross-platform. You probably don't these days have a ton of resources to write a native application for every single platform, although there's other options here for cross-platform. A really big one is auto-update. So Chrome has gone a long way to make sure that Chrome is always up to date on your desktop. It's very forceful about making sure that Chrome auto-updates. And it uses that same update mechanism to update all of the Chrome apps installed on a system. So yes, you could write your own auto-update program, but it's a hard thing to get right, and it's something that you kind of get for free with this. And so I think it's kind of one of the more compelling features of the platform. Security, it varies whether your users care about that or not. But each Chrome app runs in its own sandbox, just like a Chrome tab does. And so you're pretty safe, at least as a user if you're using Chrome apps. And of course, the Chrome's web stack. So maybe you have some web developer experience already. Maybe you already have a web app, in which case it's kind of natural and pretty easy job to package that up as a Chrome desktop app. So another question, why would you write a Chrome app instead of a web app? So this, I think, is a bit of a tougher sell. So one reason, if you're writing an app that needs to talk to Bluetooth or a USB device or some other, privileged API, then your hands are kind of tied. You can't write a web app. So that would be a really compelling reason. As I mentioned, offline support, even though web apps support it, it's kind of a discoverability issue and an expectations issue. And then number 3, integration with the native OS. So if you really want to be, have the luxury of being called an app and not a browser tab, then that would be a reason as well. Why not write a Chrome app? Well, that's not really why I'm here, is to tell you not to write a Chrome app. But really, I think you're better off with a web app. If linkability is important to you, so as you, let's bring it up here again. So by default, there's no address bar here in a Chrome app. So although the page does have a URL, there's no address bar. And also, I guess you can't see, I'm right-clicking, nothing's happening, because you define your own menus. So it's not easily linkable, and that's actually a really important feature of sharing your application. So I could myself add a URL bar in there, but you don't get it by default. And number 2, must be installed. So that's actually a hurdle to getting someone to try out your application. So for both of these reasons, you might consider sticking with a web app as an option. So what are Chrome apps for mobile? They're apps that run on Android and iOS through Apache Cordova. So this is a decal we have on our wall at work that inspires us each and every day. It's the Cordova mascot with some accessories. What are Cordova apps? Okay, forget everything I said now. We're learning about a different thing. Cordova apps. So they're apps, native apps built with HTML, JavaScript, and CSS. They're installed into the Play Store and the iOS App Store. They can use privileged APIs, so not just your regular set of JavaScript APIs. They run outside of the browser, so in their own windows. They're offline by default, and they have their own home screen icons. Let's see if I have a video to just show off one of these. Yeah, okay. So this is a kind of a typical Cordova application. It's been around for a long time, and it's a social app for beer drinking. It's called Untapped. So you can see there's an icon on the springboard there. Oh, actually, we just got into the Play Store here, so I want to show that it's installed through the Play Store. So you can see it's kind of a pretty typical mobile style app. It's got a bunch of tabs. Each one shows a different kind of list of things. Good beer spots nearby, what your friends are drinking. Okay, that's good. All right, there we go. Okay, so here's our review. Chrome apps and Cordova apps. Chrome apps are packaged and installed. Cordova apps are packaged and installed. Chrome apps have native platform integration. Cordova apps have native platform integration. Okay, so I'm not going to go down and read the whole list. I think you get the point here. They have some similarities. So, idea. Chrome apps for mobile are apps that run on Android and iOS through Apache Cordova. That was our thinking, and that's what we did. So the timeline for this was only, I guess it's close to 2.5 years ago now that we started this project. Started just by joining the actual Cordova project, contributing, fixing bugs. Then a bit later, we looked at what it would take to make Chrome apps run on top of Cordova. And then from then and still ongoing, we're adding each of these Chrome privileged APIs. So the Chrome.identity, Chrome.sockets, Chrome.bluetooth, and all of them. We've been adding those as Cordova plugins. And our current state is developer preview. So you can try it out. You can build apps. We won't stop you from putting apps in the App Store that are built with it. But we don't want to say, whole world, it's perfect. All right, so let's see another example here of a. Yeah, so this is Topeka. It was showed off at Google I/O as a web page built with Polymer. So what we did is we just turned that web app into a Chrome app, which actually was really trivial, and then packaged it up using our mobile tool. Okay, actually I'm going to pause it too because we didn't just click the icon to launch it. Actually what happened was the app received a push notification. And then from that push notification it showed a local notification on the notifications tray here. So that was the kind of way to show off that it has some native integrations. So you can see this is just showing off that Polymer in Chrome apps on Cordova actually works pretty well in its current state. Okay, I think I'm going to stop it because I don't think I get any other right after this. Huh. Okay, so what are some of the APIs that are available already on mobile? Here's a bit of a list. They're all pretty complete, but they're not all perfect, and we still create more. But the kind of interesting thing here is this bottom note, that although we're providing all of these, you can also add any of the existing Cordova plugins into your Chrome app. So that kind of broadens your available APIs that you want to use, and you can always write your own as well. So why write a Chrome app for mobile instead of a native app? So cross-platform. Yes, there are other ways of doing cross-platform on mobile, but this is definitely a compelling one. And web stack. So iOS, that means Safari. Android, that means Chrome, or Chromium anyway. And this is a common misconception, actually, that Chrome apps for mobile don't run on top of Chrome on iOS. That's not allowed. So they run on top of the system web view, which is quite good. So it's not the end of the world. But for me, I think another really compelling thing here is a better developer workflow. So I did spend a while creating the Google Docs iOS application, or I was on that team anyway. And the workflow there is just you're really recompiling your app every single time, and the turnaround time for making changes is it's not the worst, but it's quite slow. And so just having that web stack where you're editing things in line, refreshing the page, is really compelling. It really makes your development velocity really quite good. So I think that's a compelling reason. We would say developer ergonomics. So why write a Chrome app for mobile instead of a web app? So again, privileged APIs. If it's not available on the open web, then your hands are tied. Offline support, and Play Store, App Store distribution. And so this third point here is actually seemingly quite compelling because a lot of what we've seen is people write Cordova applications or Chrome apps for mobile applications that don't use any privileged APIs. And quite a few of them actually work quite poorly offline, but they really just want to be in the Play Store and in the App Store. And that's fine. So again, why not? So if you want the native look and feel, I would advise you not to write a Chrome app for mobile. And if you really want a lot of graphics performance out of your application, as of right now, I would also advise you not to. Although I'll touch on both of these later because we recognize them as problems. Okay, so let's go deeper. How to build a Chrome app. Before we dig into any code, there's one concept I'd like to, for you to all understand, and that is when I say background page or event page, those two things mean the same thing, and it's an important concept to understand. So when a Chrome app is launched, it doesn't immediately show a window. First, it creates a hidden or off-screen window, delivers the event there, and if they want, that window can then spawn a visible window. So this makes more sense in the context of, say, a push message or a Google Cloud message event, like we saw in Topeka. So in our example here, the GCM event is received, the app is loaded, and the event page is loaded, and the event is delivered there. Maybe it doesn't want to show a window, maybe instead it just wants to show a notification. Okay, so it shows a notification. And then once the app goes idle, we actually close the app. The notification's still there because that's an OS thing, but the app is actually closed. Okay, so maybe some time later, the user notices, they tap your notification, your app is then relaunched. All your HTML, Java, or all your JavaScript of your background page is reevaluated. Your event is delivered, and now the page says, okay, I want to show a window in response to this notification, so it calls the API to create a window. So generally, all Chrome apps that you see that actually show something, which is pretty much all of them, have at least two windows. They have this events page window, this background page, and they have the visible UI window. Okay, so that was your important concept. We can get into the code. So Chrome app is just a zip file of your assets plus a manifest file. Pretty common pattern here. So some highlights here is you have your name of the application, one or more scripts that comprise your background page. So these are the scripts that the runtime will load before sending any events to you. And then what permissions you want. So in this case, I'm enabling the notifications API and the GCM API. And when the user installs your app, those are the permission dialog, show up in their permissions dialog. Okay, here's how not to write a Chrome app. Although it would be really nice if this worked. So create a variable called notification, a little object-oriented programming here, which is the result of create notification.onClick. Okay, so here's your test to see if you understand the background page, why this does not work. So in this case, once your background page goes idle, it gets unloaded. Once someone clicks on your notification, what happened to your listener? It's gone, because it's kind of not a global listener. So here's how we actually would code this up. So same call to create actually. This is the real call. I just made up the fact that it returns something. It doesn't. And then you have this global event, chrome.notifications.onClicked, which you can add a listener to. So the idea here is that every time your background page loads, you register all of your global listeners. And then if your app was launched because of a notification, after your JavaScript evaluates, you registered your listeners, the event will fire, you can handle it. So you're on your own to keep track of this ID if it's important to you. And if you wanted to attach extra metadata with this notification that's not in the notification itself, you could have to use Chrome storage for that, or some sort of persistent storage for that. Okay, so hopefully that drove it home, the background page. Typically, this is what you'd see. Background.js, on launched event, Chrome app window create HTML page. So what tools would you use to do this? Well, it's actually pretty easy for desktop. basically all you need is Chrome. But two helpful add-ons to this is the Chrome Apps and Extensions Developer Tool, and then if you're really feeling adventurous, the Chrome Dev Editor, which is an IDE that we've built, which is actually itself a Chrome app, and which makes it tries to make it easier for you to build a Chrome app. So here's what these look like, unless I think we are doing all right on time. Let's have a look at them, if I can find them. All right, so if you're using the Chrome Apps and Extensions Developer Tool, the main entry point here is to load an unpacked extension. From this, you just point it at a directory which contains a manifest.json file. So a directory which is a Chrome app. And there's a button to launch it. See what the weather's like, if our network connection's working all right. That's pretty hot if it were Celsius. I'm assuming it's something else. Okay, so interesting links here too. You can open DevTools on your background page. And it actually does have a DOM, which is useful at times, but really, usually what it looks like is just empty with script tags, the ones listed in your manifest. DevTools for your foreground page. But I think this link here is pretty interesting. It's behavior. So the Chrome is trying to be helpful in recording the events that it's sent to your application, so you can see kind of what's going on. So all recent history. Read your current physical location. Now is called because the app called geolocation.getCurrentPosition. Retrieve data it had stored. Okay, so we called storage.get. Notified of onLaunched. So app.runtime.onLaunch was called, and that's probably why this app.window.create was invoked. So it's almost like a systrace, a log. But if you're not exactly sure what all of the events that is going on to your application, that's a good way to figure that out. All right. So the Chrome Dev Editor, I think we would also say this is developer preview. It's certainly early on. It was only announced at Google I/O this summer. It's got a nice create button. Let's see. And a few templates to choose from here. So we'll just do a JavaScript Chrome app, basically hello world. You can see it's created pretty much the shell manifest file that I showed you. Its index.html is basically just a header, and its background page just opens index.html. That's got a nice play button right here. And oh, look at that. And then, so the play button is just a shortcut for clicking on that load unpacked extension button. So the apps and extensions tool will work the same way with this app. When you're developing, you do get a right-click menu, which is helpful for such things such as reload application. So that just if you've changed anything, that'll pick up the things that have changed. Yeah, so I'm not going to really dig into that too much. Okay, so we talked about the background page. Here's the other gotcha that I think gets most people when they're first starting into developing a Chrome app, and that's content security policy, CSP. So it's a fairly recent web technology that's available on the open web. You enable it via some response headers from your server. But for Chrome apps, there's no server involved, and it's enabled by default. And it makes developing more annoying. But it protects against cross-site scripting attacks, and so it's actually worth the pain. And so it's not the end of the world. It's basically these two things. You can't use span on-click equals, because that's kind of a common way that if someone can get at your inner HTML, that's how they'll execute their own code. So we don't allow that. That'll throw an exception. And you can't have inline script tags. So the first one, you're kind of just doing quick throw togethers if you're using it anyway. The second one's a little bit annoying, but there's a tool written by the Polymer team that you can just throw at your HTML and it'll extract them all and put them in files. So you can just kind of hide that away in a build step if you want. That's called vulcanize --CSP. Okay. Mobile things get a lot more interesting and a little bit more complicated. So before you even can start to write code, what do you need? Well, you need the Android or iOS SDKs. You need our command line tool, our Chrome Apps developer tool for mobile. It's a companion application, so I would recommend getting that. You need Chrome and Safari for remote web inspector and remote dev tools. And then, of course, Chrome Dev Editor. And that's if you're doing real development, if you actually want to build an app, then I would say yes, you need all these tools. If you just want to build a hello world, then you can get away with just the dev editor and this number 3, our companion application, and you can actually build and test out an Android mobile application without having the native SDK. So CCA, that's our command line tool for Chrome apps. It can create fully functioning APKs and IPAs, Android and iOS applications, and you get it out of NPM, Node's package manager. So level 1, here's what you could do to use it. NPM, which of course I didn't list, but you would need that installed as well if you don't have it already. Install CCA, CCA create project, go into your project, and then CCA run Android. And that will tell the tool, okay, you've created your scaffolding project, you've added all the native bits that you need to run on Android, compile it, and push it to my connected device. If I don't have a connected device, start an emulator and put it there. So pretty nice when it just works. But the trick here is few people are able to install all of their dependencies correctly on the first try. And so we do have actually a command called checkenv to make sure that your dependencies are set up correctly. So how do you build for the Play Store or the iOS App Store? Well, that's pretty easy too. CCA build Android -- release. But of course, you need to understand how signing keys work if you're actually going to upload it. And so we have some documentation for that. What is this developer tool now for mobile? So it has the same icon as the one I showed you before, but this one runs on Android and iOS devices, and it's actually a completely separate application. But we just chose to use the same name and the same icon. And it's really our current path to a really pleasant edit refresh workflow. And I'm going to show that off here. So CCA push -- watch is what you'll type. Now that I know what to type. Okay, so here's the iOS simulator. It's just, I was looking at ways to mirror my Android device on the screen. It's just not a good, easy thing to do right now. So I'm using the iOS simulator. I'll start up our companion application. It says use CCA or Chrome Dev Editor to launch an app. Okay, so I'm over here. I'm inside Chrome App Samples, which is a Google Chrome Git repository. I'm in the weather sample app, which I loaded up on desktop. So let's see, CCA push. Oh, hold on. I typed that out already, so I wouldn't have to make a mistake. So if you have a connected Android device, you don't need to specify the target, but we're pushing to iOS here, and it's got the IP address displaying for you, so you type it in, and -- watch means push it once, and then push every time you make a change. So that's kind of nice. It pushed quite quickly. Let's see, so what do I want to do here? I want to edit our CSS, make the text darker, or a different color. Okay, so super fast, right? I mean, it's just a small application, but you can kind of get the idea. And I can change scripts here as well. It's just each time I change a file, all it does is it pushes the one file that was changed to the companion app, doesn't recompile anything, and then refreshes the page. So it's a really simple tool, but really powerful for the workflow. And you can see it is just running inside this harness. So we can stop it. You can see some details about it. Here's all the plugins that it uses. Yeah, so I don't know, I think that's really nice. I'll stop that. And we could use the, like I said, the Chrome Dev Editor as well as a menu option for deploy to mobile. All right, so that was the, what did we cover? We covered the what are Chrome apps? We covered, how to build your hello world. Now I wanted to give you some opinions on where I think things are at. So maybe let's let the pictures sink in here. This one I thought was pretty funny when I saw it. So, complicated maze to a cool castle or a straight line to a shack. And just to be clear, Chrome Apps for Mobile is Cordova, or uses Cordova. It's a very thin layer. And Cordova uses web views. So when I say hybrid apps here, I'm talking about WebView apps. We're kind of talking about the thing that got this reputation. So WebView, how did it get this reputation, this WebView? Well, for a long time, it was a debugging black box. It had no remote inspector, no dev tools, awful performance and quirks, and it was definitely a victim of Android fragmentation of every single Android, kind of tweaking the code of the WebView a little bit, and has in the past produced some comedically bad hybrid applications. So the question here is, are we crazy to be investing in this kind of a platform? Maybe at one point the answer is yes, but here's my graph. Not so quantitative, more kind of qualitative, of WebView quality over time. So 2008 is when both iOS launched their native SDK and when Android launched, and so that's when both platforms began to have a WebView. Android's kind of got better for a time, and then kind of just didn't change for a long time. During that time I was actually an application developer, and so that was a very frustrating time for me. And iOS has just kind of gotten gradually better and better and better. So 2012 is when iOS 6 came out, I believe. So that we refer to as the dark ages. So 2008, for a while, just kind of not a whole lot going for it. And then things started to pick up. Okay, so late 2012, iOS 6 launched, which, if you knew the secret command to type, you could enable Remote Web Inspector, and it was like the awesomest thing in the world. October 2013, Android KitKat launched, which had the first version of a Chrome-based WebView, which also had remote dev tools, as well as newer APIs with fewer quirks. And then look what happens to these graphs, just in the past couple of years. So let me explain why I think the graphs look like that. So July 2014, KitKat MR2 launches, WebView updates to Chrome M33. Biggest thing here was Canvas got hardware acceleration. So a lot of games especially noticed that change. August 2014, a month later, Cordova project integrates the Crosswalk WebView, which is a bundled version of Chromium that you ship with your application. That was based on M36. So now you have an option here, System WebView or ship a WebView with your application that's up to date. September, another month later, iOS 8 comes out. It has WebGL and accelerated JavaScript. Huge. Okay. October, nothing happened. It's kind of a dull month. But then November comes along. Android L is released. WebGL, WebRTC, and starting with at M37, but an auto-updating WebView. So that means, outside of Android updates through the Play Store, the WebView is going to be always up to date. So that's great for security, but that's also great for new web features and performance. So it's been an exciting year. So I think I covered this. It also has iOS 8 also had WebGL IndexedDB, which people were clamoring for a long time. Speedy. Android L, WebGL, and Web Audio, WebRTC are all new in that as well. Great support for web components. And another kind of reason that I think kind of web view competition is heating up is Facebook. So Facebook, for a long time, has been opening links on iOS inside of their in-app browser, their web view, and then just recently they made that change for Android as well. So when people open links in the Facebook app, they're opening in a web view. So we better make sure that web view works pretty well. Oh, I skipped over this kind of funny joke here. So I say this is the web view wars. It's no longer the browser wars. Maybe that's still going on. But now we have multiple wars. Okay, so how about the Apache Cordova project itself? I've been a committer on it for a couple years, and it's an Apache project. How is it going? So I think the best way to think about how it's going is looking at how many companies are involved in it. So since forever, aka since before I joined the project, I know that Adobe, who actually were the ones who bought PhoneGap and open sourced it as Cordova, I've been working on it. IBM has been working on it. And I know SAP and Telerik have downstream distributions of it and have been using it in their applications. And then, since more recently, Google, BlackBerry, Microsoft have all joined on the Cordova mailing list and been making changes and whatnot. But also Intel, Red Hat, Luday, Oracle. Oracle I just learned about yesterday at one of the talks here, the mobile application framework. So there's certainly a lot of interest in the project, especially as of late. And of course, this is kind of the same as on the web at large, but there's a lot of really nice frameworks coming out here too. Then particular to Cordova is the second one, this Ionic, which is an Angular-based framework for mobile, or for mobile hybrid apps specifically. And then Ionic Creator is their kind of WYSIWYG creator too, which is pretty cool. Okay, here's I was thinking about what works well, what doesn't work well. I want to have some actual takeaways from this if you go and build an app. So let's look at that. So what works well? I think I've maybe made this point already, but it's really important to focus on your rapid iteration cycle. So make sure you are using the companion apps. But an even better trick, and what a lot of people kind of think of on their own, is just make sure your app works as a web page. Whatever APIs you're using on the device to integrate with the accelerometer or the camera, just stub those out when running in a browser, and then you can just develop your mobile app as if it were a regular web app. Also cool with this is, choose a window. I don't know if you've all seen DevTools emulation mode. Which changes quite a bit. So you turn this on, it adjusts the viewport, and you can test out your breakpoints. I think they even added some. Let's see. iPhone 5. Some preset values here. And this is really cool. Network throttling, user agent spoofing, spoofing your sensors, emulating touch events. So there's still, I think, some things missing from this, but it's certainly a really useful resource. Okay, invest in build scripts. Kind of along the same line. See a lot of people at hackathons or just getting started, and they're just not interested in learning how to add some tools to the process, and they keep making the same bugs that can just be caught with static analysis, JS hint or JS lint or whatever. So invest in build scripts. They're really not that hard to learn these days, and they give you a lot of leverage. Authentication plugins. So this is a point I always try to make, is that if you're on a mobile device, how much do you love getting asked for your email address and your password? So I don't consider myself the fastest phone typer, but I'm not the worst, and it still drives me nuts. So Cordova, there's a really good answer for this. Chrome.identity, so the Chrome Apps plugin, will give you an API, which will you call the API, the user says okay, and then they're logged in using their Google credentials. And then likewise on Facebook, if they have the Facebook app installed, then you call the API, they click OK, you're in. So don't ask your user for a username and password. That works really well to actually get users to not hate you. Another kind of interesting tidbit of hybrid apps, which is compelling, especially I find for clients in the enterprise, is that you can update your HTML and JavaScript quite easily outside of the Play Store and outside of the App Store. So a lot of people think this is not allowed by Apple's App Store policies. It is in fact not allowed if you are updating your apps in major ways, like launching major new features or reskinning your entire application. But it's actually perfectly fine for bug fixes and tweaks or doing some A/B testing. The rules are not black and white, and it's kind of on a per case basis. And so from what I've seen, generally those are the guidelines. Like, don't launch major new features, but do some A/B testing, fix bugs. It's fine. And if you're really concerned, yeah, you should read the guidelines yourself. But it's a technically trivial problem, and I've seen it used successfully. What works well? Don't leave it. I just said develop in the browser. Please don't take away that I said only develop in the browser, especially when you're doing things like animations or touch related things. Try it on device, and try it often on device. And then maybe this is getting at a lecture point now, but I think it's quite worth it. Like, good return on investment if you spend the extra time to learn some of the tidbits about the native SDKs. Even if that was one of your reasons for wanting to build a hybrid application, is that you don't want to learn about the native SDKs, there are some kind of 5-minute sessions that make it worth it. So know what an Android manifest is on Android, know what your info plist does on iOS, maybe step through some of Cordova's native code in an IDE. Just kind of get at least a brief understanding of what's going on under the covers. Because in the end, these are native applications on the platform. And so in the end, you're kind of ultimately responsible for what it does. Okay, what not to do. So serve your application over HTTP or even HTTPS. Please don't do this. Ship your assets with your application. You can update them and then store them on the device, but don't point your start page directly at a remote page, because this just is a poor user experience, and you'll just get into the spots where a random image request fails and then you got a broken image, and it's not a good experience. Chrome apps for mobile won't even let you do this, or desktop Chrome apps won't let you do this either. Cordova will, but please don't. Multi-page applications. So this is single-page application architecture is not really a new thing. But it's actually still fairly common that people are building applications which do a full top-level navigation every time you click on a button. And that's just slow and jarring. It doesn't transition well. And so on mobile, it's even more important than ever to have nice transitions in your application and to be snappy. So please try and use a framework architect as a single-page application. What does not work well? Embedding untrusted content. CSP is not a silver bullet. So if you don't trust the script tags you're pulling in, they could do bad things. So the Cordova policy on this is just generally, there's no protection against malicious code running in your application. If you have third-party code and it does something bad, that's, we've kind of told you not to do that. And CSP is not really yet well supported in Cordova, although it's something that it's on a roadmap. So you can't even kind of turn that on as an extra protection. And by the way, this does include iframes. So a common use case is wanting to show an ad in an iframe. This would kind of be in the same boat. Please make sure you trust that ad provider if you're doing that in Cordova, or find another way to do it. Maybe through the native SDK. Okay, back to this point, which does not work well, imitating the native UI. And so this is, the word uncanny valley always comes up in this conversation. The earliest example that I could find of this was the IUI framework. So Joe Hewitt of Firebug fame, he joined Facebook, and I think this project started even before the iOS native SDK came out. So this was actually their only option for building for iOS. And so he made a web, JavaScript CSS framework for rendering native looking buttons and whatnot and controls on iOS. And the result was, it was pretty good, except after when you used it a while, it just kind of felt wrong. Then of course, OS, iOS kept changing their themes. You can never really kind of keep up. And it just kind of created this close but not quite effect. So what does not work well is trying to imitate the native UI, but what does work well is creating kind of your own brand in your application. And it sounds a lot like I'm flying in the face here of the material design that we talked a lot about, but I really don't think I am. So that brings me to the next point. The main thing I think here is just don't ignore platform-specific affordances. So the Android back button. Okay, I have a weather app on my phone, which I navigate, I hit back, and the app exits every time, and it drives me crazy. So I don't actually care that the weather app doesn't have a native-looking action bar, but I do care that the back button doesn't work correctly. And that's something that's completely within your control. Another less obvious example than iOS is if you have a scrolling page and you tap the status bar at the top, you're supposed to scroll to the top of the page so that you're not sitting here doing this, which I have an Android, so I actually do that a lot. And if someone knows a trick for that, I'd be pleased to know. But anyways, if your app doesn't do that, kind of annoys your user a little bit. But in terms of look and feel, I think create your own brand, use your own colors, and that's a big material design thing too, right? Is follow the fonts, use the right fonts, use the kind of the right white space and layouts, but create your own look and feel. So, if you just kind of do your own layout, use your own colors, but you make your toolbar the right height, that's all users I think really want. If your toolbar is too skinny, then people say, oh, this looks funny. So please pay extra attention to your white space and your layout, and also your fonts, but don't worry, I think, about having the right gradient to look like a native button. There's a lot, and especially on desktop too, there's a lot of good examples of successful desktop programs that don't look like the native operating system. Say Chrome, for example, iTunes, for example. Okay, minor point here. Don't try and do image manipulation in JavaScript. Yes, we're coming a long way to being able to do it, but we're talking about power-sensitive devices, so you really do want to do it in the most efficient way possible. So on desktop, your option here is to use NACL. And that's actually, you can compile your C++ into a binary that runs in your application, and then you can post message the result back and forth to it. It kind of runs in its own thread. And then on Cordova, this means writing a native plugin. Yes, that's a big pain in the neck. Hopefully the native thing you want to do is already written as a plugin for you. But I'd say once you get past the prototype phase, if you are doing heavy lifting, use the right technology. Okay, musings on the future. This is kind of building up to a big close here. What do I think things are going towards? So here's kind of this is the future. This is our current state. So we have apps that are quite capable, I think. Security has come a long way, OS has run each app in a sandbox. There's really locked down communication between them. Linkable. So it's kind of passable. It's not bad on Android if you implement the right APIs, but it's not really something that works by default. And on iOS, I think the most successful project is the Facebook app links thing, which again, there's some APIs that you can implement to make it linkable. And actually, iOS 8 expands that a little bit more. But I don't think we're quite there. And then ephemeral. Okay, so I didn't even know this word before it was introduced to me, but now I love it, and so I say this in every conversation that I can think to bring it up in. So that just means here one moment, gone the next. And that is, I think, the big problem to be solved in this whole landscape right now. Recent examples. Okay, you might be familiar with this first one. It's one of the DevOps schedule apps, which I had to find in the App Store, install onto my device. Then I went home, and then I brought a different device back the next day because I kind of just jumbled my devices around. So I had to install the app again. Okay, so why can't that just be, an app that's here when it knows I'm at DevOps and then automatically uninstalled later? That'd be nice. Okay, before I came to DevOps, this next one is Efteling, which is a theme park in the Netherlands. It's a great app, actually. I was really impressed with it. Tells you where you are on the map. Tells you how to get to things. but do I really need to install this giant, and it was a large one, this giant app? And I took it apart, and the main reason it was so big is it had image assets for every single resolution that you could run it on. So, low DPI, medium DPI, high DPI, extra high DPI, extra high DPI, and extra high DPI. So do I really need all of those? I feel like the web kind of has a better answer for this. Wouldn't it be nice if this app was just kind of available on my phone when I was in the theme park and then kind of gone again? And then the worst example is this third one. I was on vacation in Vancouver and I wanted to park my car, and the parking meter just has this on it: get the app. Like, I don't want to install an app just to park my car. I'm never going to use this again. But there it was. But don't worry, there actually was a secondary interface which had which everyone was using, and which had a queue forming because it was sufficiently complicated. You need to know your license plate number, and as someone who works in technology, I was not excited to see this. Okay. So what an amazing idea here. It's gotten so fast and painless. Why not skip it entirely and make a phone that has every app installed already and just downloads and runs them on the fly? Felt pretty clever until I realized I'd invented web pages. So here's the future I hope. So in my completely biased opinion, there's some really cool technologies, service worker and web manifests, that are being worked on right now, largely at Google, but also in conjunction with Mozilla and a little bit Safari and Internet Explorer. And this is really the idea to bring the idea of the Chrome app background page to the open web. So that's service worker in a nutshell, is adding this background page to web apps in a way such that they can have a lifetime which extends the life of their tab being open. It's where push notifications are delivered, and it's where you can implement a much more manageable way to do offline than what's provided by App Cache. Then Web Manifest, this is just a JSON file, very much like the Chrome Apps Manifest, only it's being run through, developed in the open with partners to be standardized, which will tell you, okay, my app has an icon. When you click that icon, I want you to go to this URL. There's a section in there where you can say, I want my app to have this service worker installed for it. So you don't need so you can actually install the service worker ahead of time. And right now it's pretty minimal, but the idea here is that we can add more and more to the manifest as we think of it. There's also, I didn't put it here, but there's a Bluetooth API being worked on, and we're really trying to get all of those native app capabilities reworked towards the open web in a safe way. Okay, but I must admit, in my unbiased opinion, another avenue here is that just make native apps, as this guy figured out, install when you want them, and then automatically uninstall when you don't want them. That would pretty much be the same effect. And so this kind of idea of being able to walk up to a vending machine and have it deliver an app to you that you can use. This kind of encapsulated a project called the Physical Web Project, which debuted quite recently. Led by Scott Jensen, a kind of leader in the UI UX field. People should be able to just walk up to any smart device, a vending machine, a poster, a toy, a bus stop, a rental car, a parking space, and not have to download an app first. So wouldn't it be cool if the NFC or Bluetooth Low Energy or geofencing, you just interact with the things around you, not having to go to a store and install an app. So we'll see what happens with it. That's kind of the end, so thank you very much. And there's 5 minutes for questions. I haven't seen really any questions being asked of these things, but feel free, or just come on down and talk to me.